Welcome to Clinical Calculations. I'm Joanne Myers. I want to clarify the difference between solving an equation using proportions and solving with dimensional analysis. You're actually solving an equation when you write the facts down as a proportion. You are actually changing the way an expression is written when you are using dimensional analysis. Students often confuse cross multiplication with how to multiply fractions. Major problem. Here's some help. Here you'll see the same problem. You are asked to administer 80 milligrams of a medication. Doesn't matter the medication. You go, you read the label, you find the correct label for the correct medication, and you see that it states there are 250 milligrams of medication per every 5 milliliters of the liquid. Now, a proportion, here we go. We have the ratio of 80 milligrams of the medication compared to a mystery, unknown amount of liquid has to be equivalent to the ratio 250 milligrams per 5 milliliters. Notice I'm keeping my units. That's fine. It's actually a good way to double check your work and make sure you come up with the right units. If you do the arithmetic and come up with the wrong units, there's a good chance your arithmetic was wrong. Anyway, in math, my two favorite rules are you can do whatever you want to both sides of an equation, pretty much. And you can always multiply anything or divide anything by a value of 1. If you multiply or divide by 1, it doesn't change the value. In this equation, if I multiply or divide both sides by the same thing, so in this case, I have 80 milligrams over x is the same thing as 250 milligrams over 5 milliliters, and I multiply both sides of the equation by my denominators, 5 milliliters times x and 5 milliliters times x. I recognize that these values will reduce when you multiply your fractions correctly, and you will be left with 5 milliliters times 80 milligrams on the left. And you'll know that that is the same thing as 250 milligrams times x on the right. Now, when we're solving an equation, we've got the equal sign. You can do whatever you want to both sides of the equation. So you divide both sides by 250 milligrams. You divide both sides by 250 milligrams. And then these units reduce. 250 divided by 250 is 1. So on the right side, I'm left with x. And on the left side, I have 5 milliliters times 80 divided by 250. Plug that all into a calculator. Five times 80 divided by 250 is 1.6. So I have proven on the left side 1.6 milliliters is the same thing as x. That is the value that will make the original equation true. If you notice, this 80 milligrams over x equal 250 milligrams over 5 milliliters looks a lot like this piece right here. This is where the cross multiplication comes in. We teach students how to cross multiply before they learn algebra. It's a shortcut. It's a trick. But if students don't thoroughly understand what's going on, it's easy to miss the fact that you are only allowed to use cross multiplication when you have two fractions that are equal to each other. For example, if I had 80 over x, and it's the same thing as 250 over 5, then you could magically write 80 times 5 is the same thing as 250 times x. The reason that's true is because you're actually multiplying both sides of your equation by the denominators and then simplifying. It's not some magic, illogical, just random thing that's going on. There is actually logic behind it. But this cool trick and shortcut only works if you have two fractions that are equal to each other. Notice in this situation here, I didn't include the units, so now you're left with 1.6 something, and you don't know if that's milliliters, milligrams, micrograms, grams. So if you keep your units in your equation, then when you end up with this number and you're in your 11.5 hour of a 12-hour shift, maybe a little bit tired, you're less likely to make a mistake. Now, dimensional analysis. Given the same information, I have to get 80 milligrams of this medication into my patient. The label says there are 250 milligrams per 5 milliliters. What I'm going to do here in this situation is start with what I'm given. I'm given 80 milligrams. Now, I am not writing an equation. I'm just writing an expression. So I'm going to start with my 80 milligrams that I'm given. I am then going to multiply by a fraction that has a value of 1. Now, any fraction has a value of 1 when the numerator and the denominator are the same thing. Well, I'm going to multiply by the ratio of 5 milliliters over 250 milligrams. Make this part bigger. That's a little easier to see. All right, so what I have written here is that 80 milligrams is the same thing as 80 milligrams multiplied by 1. So if I have 80 milligrams and I write it as 80 milligrams divided by 1, it's still 80 milligrams. If I then multiply that fraction by a fraction that has a value of 1, I want my milligrams in the denominator, so the milliliters will have to be in the numerator, so 250 milligrams is the same thing as 5 milliliters. The reason that is true is because they told us so on the label. Or if it's a test question, they told us so in the directions. 250 milligrams per 5 milliliters means that 250 milligrams is equivalent or equal to 5 milliliters of this particular medication. So I am really just multiplying by a value of 1. With dimensional analysis, we tend to put straight lines rather than have all of these parentheses. So now I've got 80 milligrams is the same thing as 80 milligrams times 5 milliliters divided by 250 milligrams, which will actually look quite similar to what we had on the other side. Yes, the proportions take a lot more room than the dimensional analysis. Continuing my work. The units cancel. 80 times 5 divided by 250. We already figured out 80 milligrams is the same thing as 1.6 milliliters. Notice the milliliters was the last man standing, last woman, last person. Personally, all I would write is given 80 milligrams. I'd say that's the same thing as 80 milligrams divided by 1 times 5 milliliters divided by 250 milligrams. The milligrams cancel, and I am left with this correct answer. So again, a side-by-side comparison of proportion versus dimensional analysis. I prefer dimensional analysis. It depends what the directions on your exam state. If the directions on your exam state you must support your work using dimensional analysis, then you have to learn dimensional analysis, even if you've already mastered proportions. If you've mastered proportions, understand they're two completely different situations. With proportions, you are given a ratio, two fractions that are equal to each other. Two ratios that are equal is called a proportion. When you're working with dimensional analysis, you are multiplying. You are just taking what's given and changing the units. If you have questions, let me know. Remember, one of the benefits of watching recordings is you can pause, you can fast forward, you can rewind. As you're watching an instructor go through problems, please pause, try and do the problem yourself, and then go back and see if you were able to do it the same way they did. Keep the questions coming.